By 2035, all new cars sold in the UK will be electric or hybrid. Most of these vehicles will have permanent magnets in their motors. By 2030, the UK has a target to deploy over 50 gigawatts of offshore wind turbines. This will require over 32 million kilos of permanent magnets. Rare earths are a vital component of permanent magnets, and right now the UK has no direct supply of them. This means UK companies wanting to produce low-carbon technologies are highly dependent on imported permanent magnets from China. However, as a rapidly increasing number of wind turbines and electric vehicles come to the end of their life, there's a growing supply of permanent magnets that need recycling. With the support of the Advanced Propulsion Centre, a company in Belfast has developed an innovative method of recycling end-of-life permanent magnets.
So Ionic Technologies has developed a technology for taking end-of-life magnets, putting them through a recycling process in order to produce 100% recycled, high-purity individual rare earth oxides. So rare earths are essential for high-technology applications such as electric vehicles and wind turbines. So this material is absolutely vital for the development of all the technologies around net zero.
Rare earths are so vital to a number of strategic technologies, they've been classified as critical minerals. Securing supplies of rare earths has become a top priority for governments around the world.
Between 80 and 90% of the world's magnets currently come from China. So there's rather a lot of sort of geopolitical challenges surrounding these materials, and certainly from a UK perspective, we don't have an indigenous supply of rare earths. We need to make sure that we have a secure supply and a resilient supply chain. If we can create our own indigenous, I suppose, urban mines to actually recycling these materials, then actually we offset the sort of the lack of a primary supply by having a secondary supply of these materials.
Rare earths aren't actually that rare. However, they are very difficult to extract and separate, so mining and refining them uses a lot of energy and acid, and also leaves a lot of waste. The Ionic Technologies method of recycling permanent magnets is a more efficient way of acquiring rare earths. But how do they do it?
So we take in magnets. First we demagnetize them. We use an oven to heat it above the Curie temperature, whereby it loses its magnetism. Then we can crush it and grind it down into a fine powder. And then we use a series of pre-treatment leaching processes to separate the rare earth metals from the non-rare earth metals. So once we've got the rare earth mixture, we use a series of mixer settlers in a solvent extraction process to separate the individual rare earths from each other.
The Advanced Propulsion Centre has helped Ionic Technologies scale their process from a Queen's University research project to industrial scale readiness.
So the APC support has been fantastic. It's enabled us to scale our technology up from pilot up to demonstrator scale. So what that means is that we now have equipment in our building that is reflective of what would exist in a commercial plant.
Ionic Technologies joined the APC's Technology Developer Accelerator program as a spin-out from Queen's University Belfast called Seren Technologies. On our program, they received one-to-one business support, funding to scale from lab to pilot. During that time, they were acquired by Ionic Technologies. They then won an ATF grant through our Scale-Up Readiness Validation competition to build a 30-ton per year demonstration plant.
The Advanced Propulsion Centre grants and support helped unlock significant foreign direct investment.
The grant from the Advanced Propulsion Centre was perfectly timed. With that grant, we were able to effectively double down on our decision for the demonstration plant at Belfast. So it gave us the confidence to spend more money and expedite the production of separated high purity magnet rare earths from recycling in Belfast, in under 12 months.
As the world deploys more and more low-carbon technology, the demand for rare earths will increase dramatically. But so too will the number of permanent magnets available for recycling. With the support of the Advanced Propulsion Centre, Ionic Technologies is poised to become a strategic component in the UK's rare earth oxide supply chain. To find out more about the work of the Advanced Propulsion Centre in supporting the UK's automotive industry transition to a low-carbon future, visit apcuk.co.uk.